Hi, Schaun Wheeler, Chief Scientist of Amp. Welcome to the show today.
Glad to be here.
So, let's just jump into this. I know, do you want to just start by talking us through your career history and an introduction to you and how you got to be the Chief Scientist at Amp?
Sure. Um, so let's see where to start. I'm a cognitive anthropologist by training. Um, so that's different from general anthropology in that it looks at how people think and organize knowledge and not just how they live. And it's different from psychology in that it's not it's not based in a lab trying to understand individual brains. It's trying to understand shared ways of thinking. So my earliest experiences in research actually were doing ethnography in a Central Asian country named Kyrgyzstan. That's a folk instrument from Kyrgyzstan back there. But my research was on uh, social movements, people who joined religious movements, who interacted with and interviewed people who had engaged in a nonviolent overthrow of their corrupt president, things like that. I basically studied how people came to make up their minds about a subject strongly enough that they were willing to sacrifice for it.
Mm.
Um, so that got me a job with the U.S. Department of the Army, of all places. At the time, the war in Afghanistan was the largest conflict that the military was involved in. And they brought in me and several other people to try to help them treat the conflict less like a military problem and more like a people problem.
Mm.
But the U.S. Army is very, very good at many things like logistics and maneuvers and taking on huge tasks on very short notice, but they aren't all that great with people. So our group was responsible for kind of making sense of all of the unstructured data coming out of the war. We ended up actually that's where I hacked myself into a data scientist. I taught myself how to code, started teaching myself machine learning. Our team was one of the very first to use machine learning for intelligence analysis in the U.S.
Oh,
government.
nice. That's cool. And do you think anthropology, that connection with how people think it's played a part in you going into agentic infrastructure for kind of marketing?
I always actually say that anthropology is the has more to do with me being a good data scientist than anything else.
Mm.
There's a data science in general, but agentic approaches to decisions in particular. Those are people problems. You're trying. It's a matter of human computer interaction. And if you go into actually just like the army went in saying, can we treat people like they're bombs and tanks? No, you can't. You can't go into human computer interaction treating a person as if they are a computer,
Mm.
as if they're just another interface with your program. So that, yeah, I find that for a while I wonder whether my background in anthropology actually was worth it. I mean, it was a lot of years to get that PhD, but I find that I use it more often than I use a lot of my methods, like my technical methods training.
Mm. Yeah, it's one of the pieces of feedback we get from our customer is, a good data scientist should be able to link it to the business problem, and it sounds like that's potentially where you started. So I'm sure it's
Yeah.
coming very worthwhile. Okay, I'm moving on. Your background in civil service, education, ad tech. I think that's a unique blend of seeing machine learning problems across different
Mhm.
industries. Um, I know problems can be very specific to certain industries, but are there any kind of common themes to machine learning that you see across those industries and how it's impacted them?
Yeah. Um, I think maybe the biggest theme I've seen is that data science is the great unkept promise. Like it was supposed to be the sexiest job of the 21st century, and people were supposed to gather all this data together and somehow get tons of value from it. And there are certainly many companies that have gotten a lot of value from their data. But that's been very unevenly distributed. If you look at the companies who pay attention to this, Gartner, VentureBeat, who do surveys on this, they estimate that what was the numbers I saw? Something between 70 and 90% of ML projects never actually get to the point where they yield value. And that tracks with my experience. Like that, there's tons and tons of hope put in machine learning and data science, but it very often doesn't come to fruition. In most companies.
Yeah, and do you think that's still the case with like agentic projects? Because I read something similar in a Harvard Business Review a while back. Around 80% of projects fail, but it was a 3-year-old study. Fast forward to today, what's happened last year is there's been a bit of a quote unquote gold rush with AI and a lot of hype. A lot of companies investing into agents. Do you think that still around? Lessons have been learned or are still around 80%.
I think it's probably more true with agentic systems than traditional ML systems. I mean, an agentic system is even less deterministic than an ML system. Like you're not just introducing a random seed in there to get your predictions. You can literally put in the exact same inputs over and over again and get entirely different responses. This is especially true if you're talking about LLMs, but any kind of agentic system is more in line with the uncertainty that you get from interacting with a human. A human can interact different ways depending on lots of different contexts. And I mean, from what I've seen so far, I mean, I know everyone is rushing for the gold in there, but there's most of the examples I've seen have been small proof of concept, very fragile, reliant on things working out just right. And as far as putting those things into production, I've seen very few examples so far that have really worked. I think we're way off there.
Yeah, interesting. And I think in your experience, just to zoom in on that a little bit, what do you think the major pitfalls of developing agents are at the moment? Where do you see people going wrong, or where do you believe people are going wrong?
I actually think it is the same problem that I've seen with more traditional ML. I've never seen a ML project fail because you couldn't get the model to converge or because you couldn't get your feature set engineered or anything like that. It's because you couldn't get the right interface with the human part of the organization. Whether that is as simple as just not being able to get buy-in from the people who need buy-in, to not really understanding the human workflows that this system is supposed to inject itself into. So there were many times throughout my career that a data scientist that I was working with, managing, mentoring, got all the way to where they had a beautiful technical product, but it couldn't get used because they realized they had built it to solve a problem that didn't actually exist. They had misunderstood the human problem. And I think that is what I'm seeing in a lot of cases with agentic systems as well. You have people who are making some pretty quick and simplistic assumptions about what the underlying problem is, and then trusting that somehow the data and the algorithms will make sense of that problem for them. But data doesn't solve your problems. That is a tool. It's not a person. And I think that's true of agentic systems as well as traditional ML.
Makes sense. Well, hopefully you can talk us through Aampe and some of the successful agentic systems that are working shortly. But yeah, just to keep it on piece with the introduction, I think one thing we like to discuss it's just some of the lessons you've learned as a data scientist. I think it's a hit and miss market for junior people with some of the AI systems coming out, and some lessons you've learned, and then with that in mind, how you would appreciate it's not silver bullets this, but how you would position yourself in the current market.
No, I would position myself. That's That one I don't know I have an answer to. That
No,
I think if I learned anything about this over my career, it's that the data science market, the tech industry in general, but especially data science, is very much a gamble in
mm,
terms of where you end up in your career. Where you're faced with trying to get hired by people who do not know actually what they want you to do. Everyone wants a sprinkling of that data science magic. But unless you are a data scientist or have worked with them extensively at a technical level, most people don't have a very vague idea of what's actually going to happen. And that makes for a very difficult hiring scenario. So, the way I handled it in my career was, I embraced that ignorance. So finding a job that isn't doing what you want to do, but because they don't know what they want you to do, it actually gives you freedom
mm,
to to steer the ship a little bit, where you have more free time maybe than you would if someone actually knew what they wanted you to do. They aren't because they can't say, are you doing X, Y, and Z if they don't know what X, Y, and Z are. But also, you have more room to go through and suggest and say, I know you want to do this very simple way of doing it, but I have this fancy tool. And maybe it's a fancy tool that you just want to learn. Um,
mm.
but there's value in that for the business, but there's value in that for you in terms of building up your skill set that you can then leverage to get into a job that's a closer fit. So um, I went through several jobs that were not a good fit for me, that I took for a variety of reasons, but a lot of the benefit I got from them was from using that as sort of an on the job training. And I think that's a very valid way to navigate a situation when there isn't consensus on what best practices look like for the most part.
Fair enough. I think, yeah, that's a really interesting approach. And in terms of engineering at the moment, you've got coding assistants like Claude or,
Yeah.
Insert Assistant. Um, would you encourage people to really focus on engineering first approaches or being really strong engineers? Or, is that time, do you think we'll all be software engineers might be replaced in 5 years, for example?
No, they're not going to be replaced. And anyone who has used anyone outside out of like that rare breed of like LinkedIn influencer who has used an LLM to code, knows that they're pretty good at boilerplate. Like if it's something like you basically, I saw the graph of like Stack Overflow traffic has been going down, 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 down. Because it's easier to find the information you need through an LLM than by searching through it there. But if you need to do anything at all off the beaten path, or if you need to do anything that requires a large multi-part code base,
Mm.
um, the LLMs aren't there yet. And I'm not sure that, I mean, to get a context window that big and to get the right attention mechanism in place to handle a context window that big, that's not I don't view that as a problem that's going to be solved really soon.
I understand.
In the end, LLMs are like, in this way, are like another person. It's like pair code. And no, I don't think anyone would ever ask, like, do you think we're reaching a place where you're going to pair code and you're just going to offload the entire job to your pair coder?
Mm.
Like it's always this conversation between you, and you do some things right, and then the pair coder like catches that thing and something you did wrong and says, "Hey, you should change this." You do the same with them. That's that kind of back and forth iterative relationship. Like I use LLMs every time I code, but it's always a very collaborative relationship and a lot of me correcting on scope, on pointing out obvious things that are wrong. If nothing else, the more you offload your coding to an LLM, the less maintainable your code base is going to be. They're incredibly redundant. They will create 3 versions of the same function and name them all different because it can't remember that it created it back there and that it does the same thing. Those are real problems if you're talking about putting a system in production. Because ultimately the LLM is not going to maintain your code base. If something breaks, you need to be able to go in and make sense of it. So yeah, I'm a skeptic on the LLMs are going to replace engineers front.
Yeah. I think that's a sensible approach, and I'm sure some software engineers listening will breathe a sigh of relief after, after hearing that. Okay, let's move on to which will break into two parts. Some about the product that you're building, how you're developing agentic infrastructure, and it's from our talks in the past, really unique approach, and then more around how you built Amped and some of the remote culture that you built, and then we'll move on to a bit of a quick fire round at the end. But yeah, just introduce people to who Amped is and an introduction to agentic infrastructure, because that may be the first time they've heard that term.
Sure. So what AMP is depends on who you're talking to. If you're in product, then AMP is an adaptive experimentation engine. It does feature validation. If you're in life cycle, it optimizes message copy, timing, frequency for every user individually. If you're in engineering, it's orchestration. If you're in data science, then it's a deployment layer for your experiments and a source of truth for those experiments. As an architect of the system, I tend to think of it as, I guess you could call it iterative alignment. So every user on any app has things they want and don't want, things they like and don't like. And we assign a dedicated agentic learner to each individual user on an app. And that agent's sole purpose in life is to adjust the holistic user experience over time for that one user to better line up that user's design, better line up with what that user wants. So it cuts across the entire user experience. It's not just messages, it's not just app screens, it's the entire interaction landscape that this agent is managing. And the idea is not to get the user to change their behavior to fit what the business wants. It's to get the business's serving of content and interactions to change dynamically to fit what the user wants. That way the user gets more of what they want, and that gets into a virtuous cycle where the business gets more of what they want because their user base is happy.
And we talked about successful agentic projects soon. What kind of companies or industries are you seeing getting the most benefit from this kind of agentic infrastructure?
So this works really well in any situation. So we primarily work with consumer apps. It works really well in any situation where the things the user does that really add value to you for you as a business are things that could happen any day. So e-commerce apps, it works extremely well with e-commerce. This is a case where, yes, some users don't have the money to spend at certain times, or aren't in market for certain things, but plausibly any user, if you get the right thing in front of them at the right time, could say, yeah, okay, I'll put out some money for that. And so in that case, the agents are very good at taking users who are already active and incrementing up their activity, taking users that aren't active and giving them undivided attention that brings them back, cross-selling, things like that. But we also, we work really well in gaming, streaming. We also do well in lots of different subscription situations. Finance management, actually streaming in some ways is both a transactional system in that you want people to watch or listen, but also a subscription system in that you want them to pay for a membership. That's a lot of ways that you make money there. So in all of those situations, we're basically dealing with users sitting around, and they could do lots of different things with their time at any given moment. And what you're trying to do is find the right moment to remind them that this particular app is one of the things they find value in. It's one of the things that they like doing.
Okay, no, that sounds super interesting. And we kind of touched on LLMs at the start of the show here. Amp doesn't rely on LLMs. Do you want to just talk us through kind of
Sure.
the advantages to some of the traditional AI methods and the unique approach that you take?
Yeah, we don't rely on LLMs really at all, but there's the option as a last stage. We actually find that very few customers take advantage of that option, usually because of concerns around quality control, brand voice, consistency. Like you don't want the LLM suddenly becoming racist or
Mm,
90% off or something like that. And so most like enterprise companies are really concerned about seeing what could go out to a user and pre-approving it. Which that so in the cases where they do use LLMs, it's usually to basically augment their human efforts to pre-populate a content inventory. So messages or content that could go on an app screen that's already been approved. But we started this before ChatGPT came on the scene. And when it did come on the scene, obviously caught a lot of people's attention, and we considered for a little bit, like, should we be using this kind of technology instead? And we pretty quickly decided that that wasn't a viable option for what we wanted to do. LLMs, not to get too wonky here, but LLMs replicate what in humans is called procedural memory. It's sequences. So you do A, then B, then C. Shuffle deck of cards, like you coordinate your muscles in a certain order. Riding a bike, writing a sentence. And that works really well in certain kinds of situations where knowing the right behavioral pattern is the key to success. So think about like a game like chess. Chess is success in chess is largely a matter of good tactics. Like you have your pieces here. Which piece do you move? Okay, you move this piece. I have 3 options. What's the best place to move? That's all very procedural, very tactical. It's what there's a psychologist named Hogarth who called this a kind learning environment. Like there's definite rules, there's stable rules. You can know what they are ahead of time. LLMs work really well in those kinds of situations. So if you go in and say, hey, I want to write this boilerplate piece of code that is like a pretty common use case, like it can say, okay, what's the right behavior, the right tokens to put together to satisfy that use case. But we found that with customer engagement, you don't have clear rules like that. It's what I've got a wicked learning environment. So there aren't rules. If there are rules, you can't know them anyway. Even if you can know them, they keep changing. And so in that case, what humans do isn't to memorize behavior patterns, because the behavior isn't going to be consistently successful because your environment keeps changing. Instead, you remember environmental cues. You learn features of the environment and say, when I recognize this kind of thing, at least I know what I'm dealing with, and then I will figure out my behavior on the fly. That uses a different kind of memory, what's called semantic memory. It's categorization. And humans take these categories of here's what's important in our environment, and we use what's called associative learning to basically add positive and negative weights onto those categories over time from our experience. So you learn that you want to go to some place to work at a cafe. And so you have several different cafes, and you know that this cafe has great Wi-Fi, but their coffee stinks. And this cafe that doesn't have great Wi-Fi. This one doesn't have outlets, but they have great muffins. Like you're taking all these experiences and putting them all together to kind of get the lay of the conceptual land. And then you make a decision based on how you feel about your different options. And that's what user engagement is. You have all of these different options for engaging users. You have just basic things like what time of day and what day of week, how often should you contact them. You have things like, I'm an e-commerce company, I sell clothing, and I could talk to them about shirts or shoes or dresses or pants. What do I talk to them about? You have value propositions, like why should they engage? You might have different incentives you can offer, different tones of voice. There's like countless things that are ways you can categorize the experience for them. And you're not going to be able to learn, oh, the user looked at this and then did this, and therefore this is obviously the way I should interact with them. That kind of behavioral stability doesn't exist in humans, period. But you can say, over time, I have found that this user, even though I sell 50 different kinds of clothing, this user only uses me for shirts and pants. Apparently they get their shoes and hats and everything like that somewhere else. So that tells me something about how I can interact with them. Either, are you in the market for the things you normally get? Let me try to do that. Or I'm going to have to make a cross-sell attempt, which is different from approaching someone who's already in the market for it. So you have to create different content for those situations. And then you could also say, well, this person doesn't so much care about price point, so incentives aren't really going to make much of a difference for them. They're willing to pay for quality, but they want to be assured that it's quality, so they want social proof. So that means I need to put together communication that emphasizes ratings, reviews people have given, popularity of the item. Is this something like a lot of people on the system are buying? Stuff like that. That's going to be more likely to succeed. And so when our agents are assigned to a user, the business populates the categories, and then the agent is going through and trying content that indexes to each of these categories. And it creates a weighting system for each category that tells it, here's how good of a bet it is. And it uses that to then drive its next decisions. So when we realized that's really what we were trying to do, was we weren't trying to optimize behavior within a session. We're trying to get behavior better over days, weeks, months. An LLM doesn't do that. An LLM, it's called catastrophic forgetting. Like they don't remember. They can't keep that much in mind. We needed an agent that had a brain that could keep that history in mind, but not the full raw history, but a consolidated, here's my lessons learned history. And that just wasn't something that LLMs aren't built to do that. They're the wrong mechanism for it. And other systems like traditional ML systems aren't built for that either. Bandits aren't built for that either. Like that was one of the biggest challenges when we realized, wow, we can't actually use nice, established, boring technology to do this. We have to figure out a different way to do it.
Yeah, it sounds like you've really tried to create something that brings as most value to the user as possible, a very unpredictable user. So I guess, kind of spoke about it before the session, how you created your RL-based system architecture. The $1 million question is how have you, built that around the user? And, we don't expect you to give the secret sauce away here, but, what's been your process there?
So we're actually pretty open about, we don't, I don't so much believe in secret sauce. So we actually try to be pretty open about this. The core idea behind the system is that instead of trying to predict what works on average for a large group of people over some period of time, like that's what A/B testing or bandits do. We want to figure out what works for each individual person at a very specific moment. So that's not common in machine learning. Standard assumption is if it worked for a group of people, it'll probably work for you. But real people don't work that way. So the first step we take is to look at a stream of behavior. In this case, it's the app event stream is what we use. But we don't just define like, okay, here's my conversion event, and we're going to try to optimize that. We actually use the entire event stream. So every button click, every screen view, every add to cart, the entire thing. If your engineers instrumented it in order for your app to work, the agent can use it. And so it goes through and we predict for each of those events the probability that the user doing that event is going to enter some kind of desired end state. That's your goal, like your conversion. The agent makes that probability judgment based on several different factors. One, it looks at the user's history. Does this user come every day, or have they not been around for 90 days? It looks at app dynamics. Is this a particularly busy time of day or busy day of week? Is it a sale day, so there's extra people on the app anyway? But then it also looks at the nature of the event. Did they just come and view the home screen, or did they come and like actually add something to their cart? It uses this to create this probability of like, here's the chance that this person right now doing this thing is moving in the direction we want. And then it drops out the information about the event itself and gets a baseline estimate of the probability. Meaning if someone did nothing at this moment in time, what are the chances they were moving in the direction we wanted? This gives us a baseline and actual estimate of directionality. This is actually something we do as humans all the time. When we're talking to people, if I'm trying to convince someone of something, I don't blindfold myself and say my whole piece and then say, okay, now I'm going to look at you and see what you thought about it. I'm watching the entire time to see how you react. And if you're looking away, if you're looking at your watch, if you're hemming and hawing, I'm going to change what I'm doing because it's clear that it's not working. Whereas if you're leaning forward, if you're engaged, if you're asking questions, I will double down on what I'm doing and keep going because it's working. We needed a way for agents to be able to do that. And so that's what this instrumentation does. And then once they have this information to be able to essentially read the room, we adapted an econometric method, difference in differences, very standard method for doing causal analysis, not normally suited for reaching conclusions based on sparse data about individual treatments. So we had to adapt it. But we basically take all of this signal that we've created, both after we send a message. So we look at what someone did afterwards, but we also look behind and say, what were they already doing at the time we sent? And then we subtract out that baseline estimate. So say, what of all of this information could have been explained by just this was business as usual for them. And then what we're looking for is the after information should be bigger than the before information. So we should see that the user was doing some things. We had an intervention, like that we engaged with them in some way, and then they did more things. And then the agent translates that into a beta distribution. So not only an estimate of how impactful was this thing, but also how confident am I that it was impactful. And then we aggregate those over time. So in the end, the agents have a profile for each user. Every action you could take at each day of the week, each value proposition gets a beta distribution for that user. That is a summary of how they have responded to individual treatments over time. And the agent is picking from those distributions and going with the actions that have the largest picks. So it says, I need to have a value proposition. I have 5 value propositions, draw from each of those and pick the largest one. If the agent has very little information, if the user hasn't responded much, those distributions are all going to be very flat and centered around a 50% probability of success, which means essentially the agent's going to randomly explore. It's just going to move around and try different things. The more someone responds to something, that distribution will go from being flat to become peaked and it'll move up. And so it will get picked a lot more often. So the agent will move from exploring to exploiting what it's learned. But if the user then changes their behavior, say you used to message them Friday at 6 o'clock, that worked really well for them to have them order food. But then they change, their life circumstances change. They get a new job, their kid has a sports program at 5, so they can't eat at that time. The agent will recognize that what they were trying isn't working anymore, and that distribution will start to flatten out again. And they'll go back into exploration. So instead of having to have a human say, let's explore now more, let's exploit now more, the agents are actually making that decision dynamically based on the feedback they're getting from the user. That's okay. That's a fire hose of information, but that's the core kind of machine that's driving the agent's decision making, is this individual assessment of, I did a thing, did it move the user in a direction? I'm then going to aggregate that information over time into these distributions and use those to make decisions about what to do next.
I think that ties in well to the next question around experimentation and model reliability. How what's your approach to research? Is it led by the model performance and how the agents are performing, or how do you actually approach that?
So we don't really have a model, not in the sense that most people use the term. Like we have some models that underlie some of it. Like for instance, we use a predictive model to get those baseline and actual probability predictions. But in terms of the agents actually making decisions, there isn't a shared model. It's not like all the agents are all like referencing the same thing. They're referencing the one user history. They will share information if they lack a decision-making criterion. If they've never tried value proposition A, they will look to other agents and say, how does value proposition A tend to play with users? Okay, now I'll decide whether I should try that one with my user. But in the end, user behavior is inherently unpredictable. In fact, we call it prediction, but it's not prediction, it's guessing. We're trying to make good bets here. So we assess the health of the system the same way you would assess the performance of a money manager. So you can a money manager can put investments in lots of different places, and if one place is not performing very well and hasn't been performing well for a little while, you might withdraw some of your money from that investment and put it somewhere that's performing better. That's really what the agents are doing. So it's not because you can confidently predict that if I put my money here, I'm getting this much return. If we did that, we'd put all of our money into the best basket. But in fact, what you want to do is hedge your bets throughout. So if the user does something spontaneous, something you didn't expect, you can still accommodate that very quickly. And if the user changes their behavior from something that was established before, you don't get locked into doing that thing over and over again just because it used to work. You should recognize pretty immediately something has changed and start hedging your bets some more. So a lot of measures of like model reliability and validity and things like that are not, I won't say they're inapplicable in this situation, but it's a different kind of game because what you're really doing is trying to find a good betting strategy, not so much trying to find some sort of accuracy measure that you're satisfied with.
I know. Well, yeah, thanks for sharing. That's super interesting. Moving on to more building AMP and less technically focused. Lots of startups start, but not everybody stays in the race. So, what were some of your challenges while building AMP? And again, it could be technical, it could be operational, strategic. What has been the real challenge for you guys?
Good question. Well, I can start with the technical one. One of the biggest challenges was that there wasn't an existing method for doing what we wanted to do.
Mm.
So A/B tests aren't adaptive. Bandits are adaptive, but they still work at an aggregate level. ML can be individual, but if you're willing to invest in it a lot, but ML isn't grounded in counterfactuals. It's wed to what it's already seen. It's not actively producing new options. Like it took us some time and a lot of trial and error to figure out how to take what we knew was already happening in the human brain, like how people make decisions about complex environments, and to make that happen in the agent. It wasn't something where we could just take an existing method off the shelf and apply that. So that was a challenge. Although I think the technical challenges were more manageable in retrospect. One of the biggest challenges we probably faced was in the very early days, we realized we'd underestimated how much time and attention and resources we would need to devote to creating a user interface for people who managed content.
Mm.
We originally assumed there's already lots of systems out there that manage messages. And we kind of assumed that, yeah, people will like build their thing there and then we will orchestrate. Like our agents will take care of deciding what to send to whom. And we learned pretty quickly that a system that's built for a non-agentic context cannot be easily adapted to an agentic one. A lot of these messaging systems are so wed to the concept of campaigns and segments, very static. I've made a decision and now I live with it kind of decisions. And that's actually like the opposite of what it means to operate agentically. And so we actually had to invest a lot of resources into building a user interface that would allow people to create content in a way that the agents would be able to act on it well. It's not just a matter of saying, "Oh yeah, I just have my CRM team do what they always do. I throw it to the agent, and the agent magically makes it make sense." It's that old garbage in, garbage out saw that you have to have the right kinds of inputs.
Okay. Cool. And speaking to you in the past, I'm completely remote for those that don't know. You got companies like Amazon and Dejassi pushing everyone back to the office. I think some startups managing to secure some real hot talent because of that. But also a lot of companies who were completely remote have now twisted and adopted a hybrid approach at the very minimum. I think you, Schaun, and Aampe are sticking by your guns, and as I say, it's something you're really proud of.
It is.
How do you manage a culture? How do you manage culture at a global scale?
So yeah, we are all over the place. I'd say at most we have 4 to 5 employees in one geographic location. And that's only true in 2 different locations. In most cases we have like one employee is in Paris. Well, like and that was important to us from the start. I mean, part of it, we actually founded AMP right at the start of the pandemic. So we had to be remote in the beginning, but also my co-founders at the time, we were all spread out all over the place. We were in North Carolina, Paris, and Singapore. And none of us had a great desire to move. So the fact that we really wanted to work together, we didn't want to work physically together because we were happy with where we were. I think that colored a lot of how we structured this, but also we knew that the decision to stay in one place carries a real cost in terms of getting the team you want, because it's not just finding people with the right skills and the right fit for the team and everything like that. It's finding people who are willing to live in the place you want them to live, and being more flexible on that allowed us to be actually a lot more stringent on the other criteria of what we were looking for in team members. I don't think our team, I mean, this is the best team I've ever worked with in my career. And I don't think it would be as good a team if we had to force people to accommodate certain geographic preferences. But it does take, it takes an adaptation. We said this often internally, and I do think it's true, that managing a fully remote team and accommodating that team requires an immense amount of trust. Like it's pretty rare actually for any of us to do like regular, like scheduled one-on-ones with our team members. Our doors are open all the time, but we aren't sitting there saying, okay, give me an update on this project. If someone takes on a project, we trust that they have that project. And that if there's a problem with that, that's going to change the delivery date or anything like that, they're going to notify us early. And in fact, we'll reach out to other teammates for help. It requires a shift for people who join us, because they're used to having a lot more oversight, of not having as much ownership over what they do. One guy that we just hired recently, I just had a conversation with him, and he just brought it out of the blue. We were just talking. He says, "Can I just say, I've never worked with an engineering team that was so willing and ready to have strong opinions about how things, how the product should be built." Engineers always have strong opinions about, no, this is bad coding practice or something like that. But they were like, no, the business shouldn't be going in this direction because of this part of the system that you don't know about because you didn't build it. And he says, normally engineers are like, okay, tell me what your requirements are. what are the constraints? When do we need this by? I'll do my best to work within that. But he said this felt like real partnering. It took some time. It still takes time whenever someone joins for us to help them get used to that and recognize that we don't uh, punish anyone for bad decisions, because the only way you make good decisions is by making bad decisions and then learning from them. So we are very, very committed to the concept of blameless retrospectives. Like we've all done stupid things. You can't not do stupid things when you're building a startup because you're moving so fast. And so when a stupid thing happens, the question isn't, why did you do that stupid thing? It's, why did we as a company have things set up that stupid thing was possible? And that it shifts the conversation a lot. So yeah, there's lots of aspects of it, of like figuring out how to deal asynchronously with tasks and stuff like that. But I think at the core, it's really a matter of allowing that level of trust and ownership at an individual level. If we bring someone on and if we feel good enough about someone to bring them onto the team, we have to feel good enough about them to let them make their own decisions, even if it's not the decision we would make. And we will do our best to accommodate that, and we will adjust iteratively as we go forward. It's not easy. It hasn't been easy, but I actually would have a hard time going back to a different way of doing things. I'm very proud of the way we've built ourselves to operate now.
Yeah, I'm the same. My words in recruitment is very traditional in the sense that everyone's in the office, and since I've founded my business working remotely, it's high degree. It sounds like you're in a good place, by the way, with a high degree of accountability and ownership, and people really struggle to go back once you make that move.
Yeah.
Would you say, I know you touched on you chose to go remote at the start of the pandemic. Would you say it's evolved in terms of your approach to, you've always been remote first, but has it evolved since the pandemic?
In a number of ways. I mean, we always have to, although I don't know that it's so much, I guess the only part that's really evolved from in pandemic to post pandemic is, we regularly will bring team members together into the same geographic area for like a week. We usually do at least one whole company trip a year. And it's a working trip. Like we do some things where, we'll be tourists for a couple of days and do some stuff like that. But for the most part, we find a really nice place to be. Nice as in the geographic location, but also like a nice hotel where we're not just like in a windowless conference room. And we will pick things to hack on for that week. There are certain problems that really don't get solved nearly as quickly or as easily remotely. Like they're things that you can have 50 calls about it and still not solve it. And then you get together for half an hour face to face and suddenly it's solved. And so, we've built that in not only for a whole team, but also I just came back a few weeks ago from Dubai where we brought all of our engineers together. We will sometimes bring the go-to-market team together. Like we do that on a regular basis. And that obviously wasn't an option during the pandemic. Other than that, I'd say most of the changes we've made to how we work remotely are less a function of we're no longer in a pandemic and more a function of our team is growing. So there are certain things that work really well when you only have to coordinate 3 people, but when you have to coordinate 30, it's just different ball. And so that kind of growth accommodation, I think, is kind of the larger driver of changes in the way we do remote.
Makes sense. Sounds like a really sensible and grown-up way to do things. So I commend you for it. Okay, and moving on to just the future and a bit of fun in terms of nobody is like, how long is a piece of string in AI at the moment? No, I guess no one can accurately predict anything beyond 6 months. But in terms of you being in the know around agents and what you're developing, where do you see agents heading, and where would you like to see them heading?
So right now, I think agents are, in terms of how people view them right now and what the assumptions they make about them, they're overwhelmingly assumed to be LLM powered. I mean, mostly if you talk to people and you mention agents, they automatically assume you're talking about an LLM. And obviously that sticks in my craw a little bit because we don't do that. But I do think that will change. There's some really important and interesting work going on regarding world models, neurosymbolic reasoning. I guess what I'm really saying is I think agents are increasingly going to have to move past this procedural paradigm of that's a good basis for making all kinds of decisions. It's actually a good basis for only making a very small subset of decisions. And I think that we're going to have to move beyond that. But obviously I'm biased.
Okay, really interesting. And yeah, what tools do you use, Schaun, to keep you productive? I know you kind of touched on your coding partner with
Yeah.
your LLM.
I'm
Yeah,
actually going
what do
to
you
use an arguing answer on this one. I use just very basic bare bones tools. I tend to use to waffle between ChatGPT and Gemini. I don't use any of the specialized ones. Partially that's just maybe my personality, but I also try to be very intentional about which tools I bring on. Um, every time we offload part of our decision making to a tool, um, we lose something as humans. Like, and that's not a new thing. That's been happening ever since we've been a species. But it's you tend to get better at thinking in certain ways and worse at thinking in the ways that you offload. That's the point of offloading. Is you don't have to think that way anymore. And so I try to be very intentional about which tools I bring on and in what situations I even use a basic LLM. I do use them all the time. I mean, I think it's an invaluable tool. Um, but yeah, I haven't spread out into a lot of the more specialized tools. That might be me with my startup founder hat on, in that I realize that a huge amount of these tools have no moat. They're like they even the ones that have large market share right now, the cost of switching to one of the alternatives is so low that like I'm waiting to see which winners emerge. So maybe it's just I don't want to learn a tool and then find out that it wasn't the winner and then I have to switch anyway. So
Yeah,
I prefer to be a little more conservative on the choice of LLM based tools.
nice. And yeah, speaking of doing your own thinking, what would be one book, podcast, or even ML paper that's really challenged the way you think, or you would recommend to someone? Yeah, what's the first one you'd recommend?
That's a hard question to pick one. Um, I I don't know if this would really be my first one, but it's the first one coming to mind. Um, there's a there's a book. It's not well known. It's actually written by a philosopher of science named Peter Achenstein. It's called The Book of Evidence. Um, it's a pretty, like, there's some formal logic in there. Like it's a dense book. Um, but it really changed the way I thought about evidence. So much of our conversation about evidence or proof or uh, a a justifiable basis for decision making is wed to thinking about particular methods or tools or experimentation setups. And that book really shifted my thinking to looking at the idea of competing hypotheses as the core thing to define, which is actually something that's pre-methodological. And you can have this really, really robust method, but if you have not defined your landscape of hypotheses correctly and robustly, the method isn't really proving what you think it's proving. And I think that opened me up a lot to considering ways of approaching evidence that could look I mean, essentially what we're doing is looking at an N of one when our agents are making decisions. That I was taught in statistics classes, that's a terrible idea. It's nonsensical. But I think there is a basis for doing it if you do the hypothesis work beforehand. So yeah, it's kind of a funny book to recommend it. Like it's not a particularly enjoyable read, but it really did change my thinking quite a bit.
Nice. I'll yeah, made a note. I'll have a look into that one. And in terms of agentic infrastructure aside, and final question by the way, um, what excites you most about AI in terms of breakthroughs? Could be robotics or what exciting change are you looking forward to the most within AI?
Um, Funny. I try to follow a good diversity of people on social media in terms of AI. So I follow a lot of the starry-eyed tech bros, and I also follow a lot of the AI is going to destroy civilization skeptics. And um and I think there's value in all of those perspectives. I mean, whenever there's a new technology that changes how people think, you can tell how influential a technology is by how many people say it's going to portend the end of the world. Like they did it with television, they did it with airplanes, they did it with bicycles. Socrates did it with writing. Like that's a common thing. And I don't want to use that to dismiss the skepticism. I share some of it. But I I think what a lot of the skeptics miss in focusing on, oh, look, there are these companies that are taking a whole bunch of data, often without the permission of the people who generated that data in the first place, and they are um, creating these machines in order to make a lot of money. And I mean, that's all true. Um, I think they're underestimating the second order impacts of these kinds of systems, especially on the way they can influence underprivileged communities, people with disabilities. Like, there's usually not a lot of money in helping people who did not have equal access to education to level the playing field. That's usually like an NGO does that. You don't get a corporation that invests in that. But that leveling of the playing field was actually one of the main, according to a New York Times article I read a while ago, was one of the main motivations behind Microsoft's investment in OpenAI. Their CTO had come from a background like that and saw that as this, like, if this can work, this is taking someone who maybe doesn't speak the way people expect them to speak. And maybe doesn't have the same kind of procedural skills that someone who had gone to 4 years of some college would have, and this can help even that out. A lot of technology, I think, in helping people who have physical disabilities is going to come out of this same kind of technology. It's the same methods, the same processes. It's just a different application. I'm actually very excited to see the way this moves into those spaces. And that touches on robotics, that touches on LMs, everything. But I think there's tons of potential there that's not going to get funded directly, but can get supported indirectly by further developing these technologies.